In the previous video, we learned how to use the difference of two squares formula to factor an expression. So let's look at the example on the left here. As you can see here, we have two terms. That's the first term, that's the second term. So usually a good tip is when you see two terms and there is a subtraction between them, you can check whether this is difference of two squares type, which means you're supposed to look for two requirements. Number one, we must have difference, which is the minus sign between them. Number two, we must have two squares. And notice here, although they are not in the form of two squares, we can rewrite 49x squared as 7x squared, because 7 squared is 49 and x squared is x squared. And also we can write 1 as 1 squared. And after we rewrite both expressions, and that is exactly the format of difference of two squares, 1 square here, 1 square there. So once we verify this is the difference of two squares formula, then we can apply the formula. So by the formula, because again the square means two copies, so we have two copies because we have two. This first expression tells us we have two copies of 7x, and the second expression tells us we have two copies of 1. So we're going to, how do we generate two copies of 7x? So we're gonna have to have 7x times 7x, and we similarly we have to have a 1 times 1. So this is what we're gonna do. We're gonna put a 7x. One of them is here, since we have two copies. One of them in the first box and the other in the second box. And same thing for 1 of them in the first box and the other in the second. And also, in order to guarantee we end up with a minus after multiplication, we have to make sure we have 1 plus 1 minus in each pair of parentheses. And again, refactoring is reversing multiplication. So we want to reverse this back to a product, a multiplication. And so we have to think backwards to think, how do we get 7x squared? Of course, 7x times 7x will give us 7x squared. And how do we get 1 squared? And 1 times 1 will give us 1 squared. How do we get minus? And that's minus, plus times minus. That gives us minus. So this is what we talked about before. But the example on the right, and notice there's a huge difference here. So the difference is we have, in this case, we have an equal sign. And if there's an equal sign, we call this a equation. So this is called a equation. But here, notice 49x squared minus 1, it doesn't have an equal sign. And so we call this a expression. So when we have an equation, we need to solve for the unknown. In this case, it's x. So we need to figure out what x is. But notice that when we factor expression, we don't know what x is because we are only given an expression. We don't know what this expression is equal to. If we don't know what this expression is equal to, then we cannot figure out what x is. But the example on the right, we do have an equal sign. So we did talk about how to use factoring to solve equations previously. When we use the GCF factoring, but we want to go over this one more time. So when we multiply numbers, whether we have 2 numbers or 3 numbers or even 4 numbers, and as long as the operation is multiplication. So again, between the parentheses, we have multiplication, and these are omitted. And the right hand side, or it could be the left hand and right hand could be switched, but we have to make sure one side is 0. So one side must be 0. The other side must be product or times, must have the times, has the operation multiplication. So if this is the case, we can say one of the factors must be 0. Factors we mean each of the parentheses. So you can set whatever in the box equal to 0. This equal to equal 0. This equals 0. And whether you have 2 of them or 3 of them or 4 of them. So this is how we use factoring to solve a equation, because this property only works for multiplication and the number 0. So that's why we have to do these following steps. So we have to make sure one side is 0. If it's not, if one side is already 0, of course we can skip this step. And then the other side, if it's product, of course you don't have to do anything, but most likely the other side is like plus or minus. So you will have to turn the plus or minus into multiplication. That process is called factoring. And finally, we can say once we turn the original equation into these two formats we need. So one side is 0, the other side has multiplication, and then you can say set finally the third step, you can set each one equal to 0. Okay, so that's what we're going to use to solve the next equation, the equation we just saw before. Okay, so let's see, 49x squared equals 1. So remember, first we have to make sure one side is 0. And notice that here, neither side is 0. So I am going to make the right side 0 to get rid of that 1. So we can subtract 1 from both sides. So I put the format here on the right corner. As you can see, this is the format you're trying to get to. So you want to make sure one side is 0. So this is my first step. I'm going to subtract 1 from both sides. And notice that the right-hand side, 1 minus 1, of course, is 0. It's not, when we have nothing, that it is denoted by 0. So we cannot just get rid of them. We do have a number 0 there. The left-hand side, since they are not like terms, be careful. Don't subtract 1 from 49 because they are not like terms. One of them has x squared, the other doesn't have. So you will just have to bring both of them down, 49x squared minus 1. Now, I do have the right-hand side 0 now. I just need to turn the left-hand side to multiplication times. Right now, we have a minus between them. So in order to turn this to product, we have to use a technique. We have learned all kinds of techniques, GCF, grouping, or in this case, difference of two squares. So if you don't know which factoring technique you should use, you can start with the first type, GCF. There's no GCF. 49 and 1, they only have 1 in common, and there's no x in common. So GCF doesn't work. And then we try grouping. And a grouping, we usually have to have 4 terms, but we only have 2 terms. And then we can try difference of two squares, and which is the case here. And since I already did the factoring on the left here, that's the example on the left, and I'm just going to bring down the answer. So after I factor this, I will get 7x. So again, I copied that answer. 7x plus 1 times 7x minus 1. But if you cannot see this directly, make sure you rewrite 49x squared and 1. Okay, so you can add a step here and put 7x, or you could do this part on your scratch paper. Okay, so now we have met both requirements. 0 on the right, left sign I have a times, so I got both satisfied. Now I can set each of them equal to 0. So again, treat each pair of parentheses like a box. So you set whatever in the box equal to 0. So the first box, we have 7x plus 1, so you set it equal to 0. In the second box, 7x minus 1, we set equal to 0. Now we have 2 equations, and remember, the final answer of the equation must be x equals something. So here, so that means we have to get x by itself. And so far, we don't have x by itself yet. So we are going to get this x by itself. And what we can do is we can get rid of plus 1 here by subtracting, and we can divide 7 to get rid of using this color. So you can subtract 1. So this is something we already did before to get net minus 1, and then divide by 7, divide by, well, actually, I already have that down here. So first we subtract 1 from both sides, and then we divide by 7 both sides. Same thing with the other one. So we can add 1 in order to get rid of something. We reverse the operation. Minus we do plus, plus we do minus. And so we actually have to solve 2 equations. And then to get rid of the 7, we just divide by 7 both sides, divide by 7 both sides. So we got one of them, it has this answer negative 1/7. The other has the answer positive 1/7. And if you have time, plug both numbers into the original equation to check. So you can plug this in here, replace x with that to see if you can get both sides equal, and plug 1/7 there. Okay, so let's look at 2 more examples here. So here I put the format up here so you can refer to, but you should have that in your mind. One side is 0, the other side times. Okay, so first of all, I'm going to look at the ones, check, see if I can find one side equal to 0. In this case, I do have a 0, so I can skip the first step. And now I'm going to have to turn that one left side to multiplication. And notice that this time, when I look at this, it does have 2 terms, but it doesn't look like we have 2 perfect squares yet. So what we can do is we can go back to those 3 types of factoring: GCF, the first type, GCF, and then grouping. Of course, this cannot be grouping here because we only have 2 terms, and then difference of 2 squares. So when I look at the left-hand side, I first check the GCF, and notice that they do have a 2 and x in common. So I'm going to take out the 2 and both of these 2's and one of the x's. So I got 2x times, so after I take 2x out, we just divide both of them by 2x. So 2 divided by 2 is 1. X third divided by x first, it's x squared. Subtract the exponents. 2 cancels 2, x cancels x. Now it looks like everything is canceled out. We should have nothing, but we have a 1, because when we say 2 and 2 canceled out, we actually doing 2 divided by 2. We should end up with a 1. Most of the time we don't put 1 there. It's because there's always something else. And for example, if you have like a x there, 1 times x will still be x. If you have a number, say 7 there, you have a 7. So we don't really need to put a 1 there, because anything times 1 is it itself. But if you don't have anything, then you have to write down the 1. Okay, so the right hand side, we just copy it. Now, and take a look at what's inside the parentheses. We still have a square. When you have a square, it is possible that we can still factor it, because x squared can be broken down as x times x. And check the factoring type, and notice that this is exactly the difference of 2 squares type. So I'm going to do that on the scratch paper. So x squared minus 1. So here I only focus on the highlighted part, and I'm not going to worry everything else. I'm just going to copy them. See, 2x, copy them, equals 0, copy them. So I'm not going to do anything here. What I'm going to work on is x squared minus 1. So x squared minus 1, and notice this 1, I can rewrite it as 1 squared. So now I have 2 copies of x and 2 copies of 1. So I am going to put 1 copy of x in the first box, another copy in the second box. And I'm going to put 1 copy in the first box and the other in the second, and make sure 1 plus 1 minus. Okay, so it's sort of like you have 2 friends, you want to give them a gift packet, and then you want to give them exact the same thing, almost the same thing. So you give you have 2 copies of x, you put 1 in each package, and 2 copies of 1, put 1 in each package. But of course, to join them, we have to have different signs, plus and minus. So this is what I'm going to put here, because x squared minus 1, I can break down further as x plus 1 times x minus 1. Okay, now when you do the factoring problems, if you are all the way down to x, because we cannot really break x down any further. So that's when you can stop. So this, it's like having 3 numbers, like something times something times something is 0. Then each of them must be 0. So I'm going to set the first one equal to 0, and I'm going to set the second one equal to 0. I'm going to